Hey, geometry students. In this lesson, we are going to be talking about finding perimeter and area with coordinates. This is not a new lesson. Okay, there's nothing that's hard about this lesson, just tedious. The stuff that you're going to do in this lesson is going to take a lot of time because to find the perimeter of different figures, what we need to do is use the distance formula or graphing to actually find how long a bunch of different segments are and add them together. But I will tell you this, if you're smart and resourceful, there are a lot of shortcuts that you can find in these problems to make them a little bit easier so that they don't take as long and they're not quite as tedious. So be smart about how you work these problems. There's going to be two of these problems I'm going to show you have shortcuts built into them, and if you use those shortcuts, they will significantly lower the time it takes to work the problems. However, no matter what, you can always go back to the long brute force way of working these problems. Even though if it takes longer, you can do it that way and get the right answer in the end. So I'm going to encourage you to be smart, but feel free to use whatever technique you need to get the answers. Letter A is one that has a shortcut way to do it. It says find the perimeter of a rectangle LMNO with coordinates L at negative 5, 3, M at negative 5, negative 1, N at 4, negative 1, and O at 4, 3. Now, here's what I notice about this. If it's a rectangle, you know that it has opposite sides congruent and opposite sides parallel. I don't know if the parallel thing is really going to matter. But the other thing that you notice is look at my x coordinate here, negative 5, x coordinate, negative 5, y coordinate, negative 1, y coordinate, negative 1, x coordinate 4, y coordinate 4. I'm sorry, x coordinate 4, x coordinate 4. This one is a y coordinate of 3. This one is a y coordinate of 3. The coordinates line up on the coordinate plane. And what that means is if I just graph this one, it's probably pretty easy for me to just count the lengths of the sides. I could also figure it out without doing too much work. However, I'm going to do this one with the distance formula just because the distance formula always works to find perimeters when you were looking for lengths between points. All I need to do is find the distance between two consecutive sets of points. So if it's rectangle LMNO, I could find LM and then MN. And then because it's a rectangle, I know whatever LM is, that's going to be the same as NO. And whatever MN is, that's going to be the same as LO. Okay, so let's figure out LM first using the distance formula. Because we have points that line up, this is going to be really easy to use the distance formula anyway. So I'm going to do x2 minus x1. Well, negative 5 minus negative 5 is just 0. So this is actually going to cancel out. Plus, I have to square that, and then plus y2 minus y1. Negative 1 minus 3, which is going to be negative 4 squared. So let's go ahead and work that out. The first term turns to 0. The second term is just negative 4 squared. This is going to be the square root of negative 4 squared, or the square root of 16, which is going to just turn into 4. The side length LM has a length of 4. That means also remember that NO has a length of 4. But let's do MN next. Okay, these 2 points. The distance between those using the distance formula is going to be, let's see, x2 minus x1, 4 minus negative 5 squared, plus y2 minus y1, negative 1 minus negative 1. Well, negative 1 minus negative 1 is just going to become 0. So here again, I'm just going to have one term. It's going to be the square root of 9 squared. 9 squared is 81. Take the square root of that, I get 9. The square root of 9 squared is 9. All right, now I actually have two sides that are 4 and two sides that are 9. I add those together, I get 26. We should have a perimeter of 26 for the rectangle. There we go. Letter B, find the perimeter of triangle PQR. No shortcuts on this one, folks. You're actually going to have to find the length PQ, QR, and then PR We have no idea what kind of triangle this is. We don't know if it's like equilateral, so I could just find one side and add them all together, or isosceles, so I just have to find two. We're going to have to find all three sides. Also, there's a little hint here when it says round your answer to the nearest hundredth. That tells me I'm probably not going to get easily calculatable results. So let's go ahead and do this one. We're going to have to use that distance formula again for perimeter. Okay. So the perimeter PQR, we're going to start with PQ. It's going to be x2 minus x1, so 9 minus 4, squared, plus y2 minus y1, 3 minus negative 1 squared. That simplifies to 5 squared plus 4 squared, which is going to be 41. 25 plus 16 is 41. But I need to take the square root of 41. I need to punch it into a calculator because that is not a simple square root to figure out. And it ends up being something like 6.40. Okay, next let's figure out QR. Same distance formula. X2 minus x1, 6 minus 9, 6 minus 9, squared plus y2 minus y1, negative 4 minus 3 squared. So it's going to be 3. Let's see, this is going to actually be negative 3 squared plus negative 7 squared. So the negatives are just going to go away. But it's going to be, this should be technically negative 3 squared. It doesn't really matter because the negative 3, when you square it, the negative goes away. So this would be 9 plus 49, which is 58. I do the square root of 58 because the distance formula has a square root built into it. Square root of 58 is 7.62. I don't think it'll mess things up too much if I put a negative here. I do need to make sure that this is in parentheses. There, that's the correct formula here. All right, and then lastly, I'm going to do the distance between PR. So I did PQ, I did QR, now I need to do PR. PR is going to be, let's see, x2 minus x1, 6 minus 4 squared plus negative 4 minus a negative 1 squared. Here we have some negatives management. I'm going to have to do negative 4 minus negative 1 is plus 1. So this is going to turn into 2 squared. Here, this is 2 squared plus negative 3 squared. That's going to be 4 plus 9 is 13. The square root of 13 is 3.61. All right, so I've got these three side lengths. What do I have to do to find the perimeter? I have to add the three side lengths together. I find a perimeter of 17.62. Let's just see if we got that right. Oh, hold on. That was the wrong one. Ooh, revealed the next one, 17.62. All right, now, letter C is actually an easy one that looks like a hard one. But I am going to say this. Sometimes when you have to calculate the area, you are going to have to do some tough calculations. So I could use the distance formula to find the length of YZ. I could use the distance formula to find the point that's closest to YZ, the distance between YZ and X. Remember, we've done that before. The distance between a line and the point closest to the line. Um, if if this were a problem that was a little harder, I might have to do something like that because um, I need to figure out. So to find the area of a triangle, I need the base times the altitude times 1/2. Now we have to remember what that means. The altitude is, you can choose any side to be your base. But if you choose whatever side you choose to be the base of your triangle, you need an altitude that's perpendicular to that side. Now that can be really hard. If I chose XZ to be my base, I'd have to figure out an altitude perpendicular to XZ. I could do that. I could figure out um, the distance between the line XZ and point Y. We've done that before. You'd have to figure out the slope and then the perpendicular line and then figure out where the perpendicular line crosses line XZ. We could find that point, then use distance formula to find the distance between that point and Y. It's a lot of work. It's a lot of work. And sometimes you're just going to have to do a lot of work. Now, on this one, though, you can be smart. Hey, are any of these lines aligned with the grid of the coordinate plane? Hey, I noticed that YZ is perfectly aligned with the grid of the coordinate plane. And does that one that's perfectly aligned have an altitude that's perpendicular to it? Well, look at that. The altitude that I drop from X over to YZ is going to be perpendicular. So if I use YZ as my base and X to whatever the point is right here, so this would be my altitude from X to that line as the altitude, I can easily just do 1/2 the distance YZ times the altitude. So YZ, if I just count 1, 2, 3, 4, 5, 6, it's 6 units long. And X is 1, 2, 3, 4 units. So my altitude is 4. That's going to look like this: 1/2 times the base, 6, times the altitude, 4. And this only works because this triangle is lined up just right for me to count the length of the altitude perpendicular to the base if I choose YZ to be my base. Okay, what do we have to know? You have to know that you need to choose a base. Any side can be the base, but then you need to figure out an altitude that's perpendicular to that base and what the length of it is. So if you're smart, you can figure out the easy way to do this. We already revealed the answer to this one was 12, so we figured that out.